there, welcome back to Big Data Tutorial. I am Shiva, and today we are diving into an exciting educational journey. In this video, we are going to unravel the mystery of Hadoop and its component, and by the end of it, you will have a solid grasp of the key concept. Whether you are a curious beginner or someone looking to deepen your knowledge, you are in the right place. We have crafted this video to be informative, engaging, and most importantly, easy to follow. But before we jump into the nitty gritty, make sure you hit the subscribe button and ring the notification bell so you never miss an update from us. Learning is a journey, and we are excited to have you along with the ride. All right, no more delay. Let's get started with the topic Hadoop and its component. So today's agenda is what we'll learn about what is Hadoop, Hadoop evolution, and Hadoop components, and later we'll see about Hadoop ecosystem. So Hadoop is an open source framework designed to process and store large volume of data in distributed computing environment. It provides a scalable, reliable, and cost-effective solution for handling and analyzing massive dataset across cluster of computers. Hadoop was created by the Apache Software Foundation and has become a cornerstone of the big data ecosystem. Okay, so in 1999, Apache Software Foundation, that is called ASF, formed as a non-profit organization in 1999, and in 2002 Notch created by Duck Cutting and Mike Caffarella. In 2003 Google released a paper to describe how to store the large data set. Okay, and in 2003 only this paper was called as a GFS, Google File System. In 2004, Google released a paper to describe how to process large data set. So in 2003, Google released a paper how to store the data set, and in 2004, Google released a paper to describe how to process large data sets. That is called MapReduce. That is known as a MapReduce. In 2006, Duck Cutting joined Yahoo. Hadoop spins out of Notch project. The implementation of GFS was named as a HDFS, Hadoop Distributed File System. The implementation of MapReduce was named as a MapReduce, unchanged. Duck cutting joins Cloudera and fastest sort of 1 TB of fastest sort of TB in 62 seconds over for 1460 nodes, sorted at PB in 16.25 hours over 3658 nodes. In Hadoop 1.0, it was HDFS for distributed storage and it was MapReduce for distributed processing. In 2011, Hadoop came under Apache Software Foundation and became open source project. Hadoop stable version 1.1 was released in 2011. Apache released Hadoop 2.0 to provide major performance enhancement with Yarn. It means there is one another component known as a Yarn included into the Apache, like Hadoop. 2007 and 2021, Apache released Hadoop 3.0 and Hadoop 3.3.0 is the latest version of Hadoop as of now. Means what is the latest version we have? 3.3.0. So this is evolution of timeline. We can say this is the timeline of Hadoop, and now we'll learn about the Hadoop component. So Hadoop, if I talk about the Hadoop, so there are two different version, or nowadays three, another new version is there. But in Hadoop 1.0 and in Hadoop 2.0, there is one major differences is what in Hadoop 1.0 there was only two component, MapReduce for processing part and HDFS for storing part. But from 2.0 there is one more component added, that is called yarn. Map, as it is, map is used for to parallel processing. HDFS is used to storing data in distributed manner, and yarn here came into existence, and yarn will be used as a resource negotiator. Yet another resource negotiator means it will check the availability of systems, resources, and on the basis of that it will provide the jobs to the different resources. So this is the difference between Hadoop 1.0 and 2.0. So the main core component of Hadoop is what? HDFS, MapReduce, and yarn. HDFS for distributed storage, MR for distributed processing, and yarn for resource management. HDFS, we'll talk about it. HDFS means Hadoop Distributed File System. HDFS is the primary storage system of Hadoop. Means this is the primary storage system. It divides large file into smaller block and distributes these block across a cluster of machines. This architecture allows for efficient storage and retrieval of data as well as fault tolerance. So those for those things we have taken, we have accepted HDFS. Okay, now, okay, you can see here, this is the master node and these are the data nodes. So it means there will be one master node and there will be multiple data nodes, and all the data nodes will be responsible for restoring the data with the help of HDFS, and uh, will be responsible for processing with the help of MapReduce. Okay, so these are the called master slave architecture also, you can say. And MapReduce. What is MapReduce? So MapReduce is a programming model and processing engine that enables the parallel processing of large data sets. That means parallel processing will be done. It breaks down complex computation into two main phases. What are the main phases? The map phase, where the data is filtered and transformed, and reduced and reduce phase, where results are aggregated and summarized. Okay, so these are the two different phases in MapReduce. Mapping means where the data filtered and transformed in mapping, and in the reduce phase where the results are aggregated and summarized. Okay, you can see here there are different block. So one map is working here, another map is working here, on another map is working here. Okay, so these are called mapper, and this is here is a reducer. Then after that, like if you need to give the output, then what it will do, combiner will combine all the data from maps, and after that there will be a reducer which will reduce the all the, like it will collect all the data from different nodes, and then it will send the out as a output. What is yarn? So yarn is, as the name suggests, yarn means yet another resource negotiator, mainly responsible for resource management. Like what is the resource management? Means managing the systems, managing the nodes of a cluster. Like if I talk about, there are many systems. So there are many system connected with each other and creating a cluster. So yarn will be responsible for checking all the systems, it is working properly or not. Okay, slowness, those are things. So, and yarn is a resource management and job scheduling component of Hadoop. It allow multiple data processing engine such as MapReduce, Spark, and Hive to share and allocate resources on Hadoop cluster. Okay, Now we'll learn about the Hadoop ecosystem. Hadoop ecosystem means family or the environment we can say. So in Hadoop ecosystem there are different tools available. Like in core there will be HDFS, YAN and MR, MapReduce. So these all will be the core component, and like this is a Hadoop core component. And rather than this, we have a different tools available. Okay, like a Sqoop. A Sqoop will be used for a data ingestion, data export and import. Okay, a Spark, as we know that the Spark will be used for a in computation, in memory computation. Okay, pig is also something like Spark only, and Oozie will be used for a scheduling job, and Hive will be used for Hive is actual query language, so it will communicate with the databases or distributed data system. Okay, HBase is another tools, and we'll see one by one later. Hive, like data warehouse, Hive is a data warehouse tool built on top of Apache Hadoop for providing data query and analysis. So Hive will be used for a Hive is a data warehouse tool. Hive is a data warehouse tool to built on top of Apache Hadoop. So this is Hive, and Pig, a scripting language for data manipulation. Like in the place of Pig, we will be using PySpark or Spark. So, but Pig was also as a scripting language for data manipulation, transforms unstructured data into structured format, runs on top Apache Hadoop. Like whatever the data we have. So first of all, we need to transform that unstructured data into structured data, and then it will be useful. So this is big, and this is a scripting language. This is a Sqoop, a command line interface for transferring data between RDBMS and Hadoop and vice versa. Like as I told you, a Sqoop is an ingestion tool, like data ingestion. If you can import data with the help of a Sqoop, and you can export data with the help of a Sqoop. Okay, now HBase, a column oriented, no SQL, not only SQL database that runs on top of HDFS. So this is also uh, another tool of a Hadoop ecosystem, and a column oriented, no SQL, not only SQL database that runs on a top of it. It means HBase is running on top of HDFS. Oozie, a workflow scheduling system to manage Apache Hadoop jobs. So this will manage our jobs or scheduling jobs. Spark is a distributed general purpose in-memory compute engine. A Spark is a general purpose in-memory compute engine. Okay. Now we'll see about some more about a Spark. What is a Spark? So Apache Spark is a general purpose in-memory compute engine. In Hadoop cluster, HDFS will be used for a storage unit. MapReduce will be used as a compute engine, and YARN will be used as a resource management. So Apache Spark will be used where it will be used in a MapReduce format, MapReduce part. In Hadoop cluster, HDFS will connect with HDFS. MapReduce, there are two different things. Either in MapReduce you can use Spark also, that is called compute engine, and YARN is there only to resource allocator. Now Spark is a plug and play compute engine. Like if you have a Spark one, then you can only that just plug and play. You can just add some codes, and you can run. Now introduction to Spark. Spark cluster. What are the different cluster? Like compute, resource manager, and storage. Okay, these are the Spark cluster. So, and industry current trend, what is saying? It is saying for computation part we are using, like for computation part market is using Spark. For resource management part, market is using Yarn, and storage, for storage HDFS is there only. So these are introduction of Spark, and Spark is written in Scala. So you have to understand, a Spark is a not language. Spark is written in Scala. However, a Spark officially supports a Scala, Python, Java, and R. It means A Spark will support you for different language: Scala, Python, Java, and R. So, and there you have it, a comprehensive exploration of big data ecosystem. I hope you have enjoyed this video as much I have enjoyed creating it for you. Remember, learning doesn't stop here. There is a whole world of knowledge waiting for you. So keep exploring, keep asking questions, and keep that curiosity alive. If you found this video helpful, don't forget to give it a thumbs up and share it with anyone you think might be benefit from it. Your support fuels our passion for creating more educational content. And if you haven't already be sure to subscribe to our channel and turn on those notifications so you never miss out our latest video. Thank you so much for watching, and until next time, keep learning, keep growing. This is your Shiva from Big Data Tutorial, signing off. Thank you.